Hannah's on. Hannah, you better have your school uniform on since you're not visually present. Okay, so we got the etch and sketch. We have that, right? And then we've got, I got a question. If I go from Carroll to Des Moines, because I got to catch a flight instead of drive one state over. Oh, that's Illinois. And it's 100 miles, and I get there in 2 hours. How fast did I go? 50 miles per hour, right? So, but is it really 50 mile an hour? Do you go just 50 mile an hour the whole time? What type of rate of change is that? Huh? You're saying it. Average rate of change is an average rate of change, right? But you got to slow down to at least 45 when you're going through Glidden, right? I kind of speed up going through Glidden, but anyway, oh shoot, this is recorded. Anyway, so you got to slow down at Glidden, then you speed up again, right? And you slow down, speed up, you get pulled over for speeding or whatever, and then you say, well, I had to go golfing out of town, and then they're like, oh yeah, just get going. Just call it a meeting. All right. But anyway, that only happened to me once. So, all right. So anyway, that's an average rate of change. So let me change over here to the screen. And then we'll see if you got any questions. Did you get a chance to do any odds yet or not? Okay. So it's pretty good overall. But if I've got, you know, what is average rate of change? Average, that was average velocity, right? So average velocity is change in distance over change in time, right? So delta S, change in distance over change in time, right? Delta T, ds dt. But if I want instantaneous velocity, what is it? So like basically, you know, if I'm instantaneous velocity, so that's any velocity at any moment in time. Remember, velocity is speed and direction. That's going to be, velocity is what? V of t is going to be s prime at t, right? So the derivative, really, this is going to be the limit as delta t goes to 0 of delta s over delta t. I know that s looks like another delta, but it's a lowercase. Isn't it? So it's the limit of the basically secant line, right? So same like we had before. It's my head. You gotta tell me if my head's in the way. I think I can get off to the side, maybe. But does that make sense? By the way, sometimes this is all in videos too, but you know, sometimes they're gonna do you know, s instead of s of t. Sometimes they call this f of t, like your function. Sometimes they use f instead of s. So sometimes they say s equals f of t, which is kind of dumb. But anyway, like you have y equals f of x, right? So some people don't like s as a function, so they call it f of t. But it could really, s is a position function at time t. So s is your position, d is your, the velocity is your instantaneous rate of change of position, ds dt, right? Or s prime. And then, so remember, velocity, ds dt, s prime, so that little d is an instantaneous or a tiny change, right? So delta is kind of a bigger change over space. D, the little d, is a tiny change, infinitesimal change. Do you have a question on any of the odds? Did anybody do any odds? Because you're supposed to do the odds. Like, I don't know why you didn't do the odds, but. I don't know which ones I did in the like I have ones in my notes. I think that's the ones I did in videos. So if there's an odd exercise that you would like me to throw up here. Anything? You want me to look at? So 2-5, I want you to have evens done by tomorrow, and then read or watch videos on 2-6. All right. We got here. We could do. Didn't I do number 21 in videos? A rocket being shot up in the air. Okay, was there one? There is one that's wrong in the back. Number 9 has negative time in the back. So number 9, you can't have negative time, right? So let's just look at number 9. Let's just do that one. I don't think I did that one, did I? So section 2.5, number 9, what do we got? We got S equals T cubed. Then what? Can somebody read that to me?
Plus 3t squared minus 9t plus 4.
Okay, so that's a position function anytime t. Now we know that time starts at 0, right? So what's the initial position? Where are we at? So ultimately, I want to graph this thing. So here's my position function. Remember, it's rectilinear motion. It's just back and forth on line. And if we're at 0 here, where are we at the start? Where are you at? At 4, right? I'm to the right, 4. So here's 4. So this is where I start. This is my particle start. So the initial position, S of 0 equals 4. That's my start point. Starting position. Also known as S sub 0 at times, right? But it's S evaluated at 0. It's the position at time 0. So anyway, once again, S is a function of t, so calling it f of t or s of t really doesn't matter. So I don't change it over and call it f of t because I know that s is a function of t, right? Because you can see it. But you can call it s of t as easily as you can s of t. All right, so then what's it ask for here? What are we trying to do on this? Particle moving, so directed distance. Positive direction is to the right. Interval when it's moving to the right, and interval is when it's moving to the left, and then when it stops. So when do you basically what we need to know is does it go right or left? Well, you could plug in 1. If I plug in 1, I'm going to get 1 plus 3 is 4 minus 9 is negative 5. What? Yeah, plus 4 is negative 1, right? So at 1 second, I'm over at negative 1, correct? But do you know that you start out going left just because I plug in 1 and get minus 1? This is at t equals 0, and this is at t equals 1 second. Do you know that you go left right away? No, because I could go right for half a second and then turn around and go back to the left, couldn't I? So how do we find that out? When do we stop? When are you stopped? When the velocity is 0. So if the velocity is positive, which direction are you moving? In this case, to the right. If the velocity is negative, you're moving left. If the velocity is 0, you're stopped, correct? So what do we want to find out? So you're stopped when velocity, v of t, which is s prime at t, right, equals 0. Everybody agree with that? So basically, what do we do to find out the velocity? What is the velocity? It's the derivative of ds dt, right? Okay, so 3t squared plus 6t minus 9. Set that equal to 0. And then, of course, I can, if in doubt, factor it out. I can factor out a 3 and divide through by that, right? So it's 3 times the quantity t squared plus 2t minus 3. Everybody agree? Equals 0. And is everybody okay if I just cancel out that 3, dividing both sides by 3? And then when you have a quadratic, you can always use a quadratic formula, but if you can factor it, so this would be t plus 3 equals 0, or t plus 3 times t minus 1, right, equals 0. So what does that say? T equals negative 3 or t equals 1, right? Okay, well, which one of those can I use? T equals 1, we're stopped. It also says we're stopped when t equals minus 3. Does that even make sense? That doesn't make sense, does it? So that's negative time. You can't have negative time. We can't go backwards in time. So at 1 second, we're stopped. Okay, so but when I plug in 1 second, I'm left, if I did it right, s of 1, we have that s of 1 equals negative 1, correct? So which way did I have to go to get to that stop point? I had to go left, correct? Now, for those of you that don't like football, I apologize because you shouldn't have took me as a professor. Limited choice, right? But anyway, so you can stop and turn around, or you can stop and go, like a hitch and go, like you stop and then keep going in that direction. So I could continue going left after I stop, or I could stop and turn around and go back to the right. So what do we do? How do you find out? You can plug in another number, right? So you can plug in any number you want, but if I just plug in 2, I'm not going to stop again. Okay, so I just got to figure out when I plug in 2, what do you get? You get 8 plus 12 is 20, minus 18 is 2 plus 4 is 6, correct? Which is to the right. So basically, I stopped and turned around and went to the right. Okay, so here's my graph of that. Sorry, here's my graph. And instead of doing it on the back and forth on that line, I draw it above for visual separation. Okay, now that's not what it asked, though. What it asked is to come up with a chart, right? So then I did this in my videos too. So what I would do is I would split it up. So I would have my interval. So I'm just going to call it INT for interval. Then I'd have my testes. That's funny. There. Not really. Then I would need my, how do you know which direction you're going? I would need the sine of my velocity, the sine of v, right? And then my conclusion for the particle. So usually I wrote conclusion for f, but f can mean position, so I'm not going to do that. I just need my conclusion. So basically, where do I split this up? I'm going to split it up with critical numbers. So what are the critical numbers? Critical numbers are where, so basically, the derivative of s prime equals 0 or does not exist. Okay, so we're not really into critical numbers yet. We'll get into that more in the derivatives, but where the derivative is 0 or does not exist, I'm going to split this up. So s prime is what? It's my velocity. Because velocity equals 0, I'm stopped, right? Okay, so what are my critical numbers? That's when t equals 1, correct? So basically, I want to see what's going on left of that. So 0 is less than or equal to t is less than 1. I need to see what's going on there, right? I've already graphed this, so we already know because I plotted in points, right? So we know what it looks like and what's happening. But I want to show you if I didn't do that, we could use this chart. T equals 1, and then t is greater than 1. And that's going to include everything, right? Because the domain of t is all positive reals, including 0. So we do not graph negative numbers, unlike what they did for number 9 in the back of the book, which is incorrect. All right, so what t do you want to choose between 0 and 1? Okay, I could do a half. You could actually plug in 0 if you wanted, because it's not going to change. And then here, I'm just going to pick an easy number. We'll pick 2. So the sine of v, of course, what was v? V was what? I'll do this in a different color below. What was the velocity? It was 2t squared minus 6t plus 6t minus 9, right? Which honestly, it was 3 times what do we factor that as? T plus 3 times t minus 1. All right, does that 3 matter for the sign of what velocity is? Not really, right? But you could plug it into this. Like I could plug in a half, and it's 3 times a half squared plus 6 times a half minus 9. Is that positive or negative? And your answer is? I already know it's negative, but how do you know it's negative? You'd have to plug it into your calculator, right? So when I was helping my son with algebra last night and he was grabbing his calculator, what do you think? I got pissed off like no other. I'm like, why are you using your calculator? Well, that's what we're doing in class. I don't care what you're doing in class. I care that you know how to do it, right? So in this case, what's an easy way to do it? Easy way is not taking a half and plugging it in to V, is it? If I've already got a factor and I know that a positive number times anything is it's not gonna change the sign, I can ignore the 3, right? But if I plug a half into t plus 3, is that gonna be positive or negative? I don't care that it's 3.5, I just care that it's positive, right? And if I plug a half into t minus 1, it ends up being negative 1. I don't care that it's negative a half. I don't care that it's negative a half. I care that it's a negative, right? So if you plug a half into these right there, I'll get a positive times a negative, which is negative. So it's negative. So what's your conclusion for your particle? Which way is it moving? If the velocity is negative, left. It's moving left. You're going left. Okay? And of course, at t equals 1, the velocity, if I plug that in, I get 0, right? So then it's stopped. Now, the only thing you don't know is if it's stopped and going to continue to go left, like a hitch and go, or it's in the negative direction, or if it's going to stop and turn around. We need to plug in 2. Well, once again, I'll let you plug in 2. Instead of plugging it in to figure out what it is, you're just figuring out what the sign of it is. So what is it? Positive, because 2 plus 3 is positive, 2 minus 1 is positive, so it's positive times positive, which is positive, so it moves right. Do you agree? So then now that I know I went from left to right, that's a right. I went from left to right, I can say it stopped, and then TA means turn around. So I stopped and turned around. Does that make sense? And then we can just plug in those, like plug in some specific values, like per point, and then where you're at t equals 1, and then I got my graph that I just put up there, right? Okay. So anyway, hopefully that helps. And then, I don't know, is there any other odd exercise we need to do or things like that? 25, did I do 25 on the, I'm not sure which we did. I didn't do 25. I do want to talk about pole today too. So acceleration is pole, so we do need that as well. Did I do, what one did you say I did in the videos? 21?
Yeah.
Okay. By the way, we have, when you have gravity, so let's talk about that. On page 153, there is a formula. It's formula number 10. So this is page 153, formula number 10. Okay, and it says this: if you have something with gravity, from physics, we know that basically gravity. What's a gravitational pull? Anybody know? Anybody in physics? I thought you were in physics. Negative 9.81 what is labeled? Meters per second squared. Okay, right? So that's gravitational pull, or negative 32 or 32.1, I think, feet per second squared. I don't. Yeah, I can just. Yeah, that S is not the same as the second, or not the same as position. That's second, right? Anyway, but it's negative because up is positive, right? We always think of up as positive, down as negative, so toward the earth, right? So that's a gravitational pull. So you're going to see eventually, because of calculus, physics uses something called the position function is going to be minus t squared, and then plus v sub 0 t, the original velocity, times t, and then plus your original position is going to be the vertical position, ignoring wind resistance, right? We all know that, like, you've seen the story, like, if you fall out of a plane, are you going to survive? Probably not, right? But there have been people that have, because they slow themselves down and then just hit lucky enough on the ground to not splat, right? So it doesn't happen very often. Don't try it, right? I don't even know if you can survive a fall like that into water if you're high enough up, right? Because the water becomes hard. So don't try it. But anyway, wind resistance can come into play. So this is ignoring wind resistance, right? What falls faster, a piece of paper or a rock? Here, I'll give you one. What falls faster? Hannah should probably see this. This is awesome. Okay. So I got a paper towel, and I'm not going to drop it very far. I got a paper towel and a pen. I don't really want to touch that pen. I got one in my pocket. Okay, can you see these? Okay, my question is, which one's going to hit the ground first? Pick. Well, you're right. It was the pen. Okay, bad example. Ready? Can you still see me? No. Basically the same time, right? And there's still no wind resistance, but it's the same thing, right? Same time. Pretty cool, huh? That's what I thought. You couldn't see that, but they hit at the same time, but I crumpled it up. So anyway, all right, now go back. Wait a minute. Okay. So anyway, going back, why doesn't it go to that? Go to the whiteboard. Oh, there it is. Okay. Anyway, so we come up with that. We have different positions, things like that. So I did that one. Do you need, I guess, what else do you need to see? You don't even know because you didn't do enough work going into today, right? So I could just say, well, guess you got to do it. You want me to do one? Let's look at, I got an example. So I'll do one more for you here, apparently. So here's an example. If I've got S equals 1/3 t cubed minus 5t squared plus 16t minus 2. Did I do this one before? The question is, we want to graph this so we can come up with a chart, okay, for velocity. I think I did this one on the videos too, didn't I? But anyway, if I want to come up with a chart and I want to find out, like, I want to graph this thing, and I want to see when it's moving right, when it's moving left, when it stopped, right? So there's my position, S of t, 0's there, okay? Anyway, what's the first thing I'm going to do? Find the derivative, right? So the velocity is ds dt, right, or s prime, is what? It's going to be, what's the derivative of that thing? Using our theorems. Carter, you look like you didn't want to answer. What's the derivative of the top equation there? Yeah, I called on you because I knew you'd know. So anyway. All right, so we got that, right? So then the question is, when is this sucker stopped? So we're going to set that equal to 0, right? You're stopped when the velocity equals 0. I'm not going to write that down. I said it, but you're stopped when the velocity equals 0. So where does this equal 0? I'm just going to change colors here. So this equals 0. We can factor it, right? So if in doubt, factor it out. If you can't factor it, what do we do? Quadratic formula, negative b plus or minus square root of b squared minus 4ac all over 2a. Where'd that come from? Thank you. So it's t minus 8 times t minus 2. Is that correct?
Yep.
Or t minus 2 times t minus 8 if you like it in alphabetical order. It's not alphabetical. It's numerical order. But anyway, actually it's not. Negative 8 is left of negative 2. Gotcha. Anyway, that's why t minus 8 is on the left. So this says t minus 8 equals 0 or t minus 2 equals 0, which says that t equals 8 or t equals 2. Now that's not in order. To what? Seconds, right? So in this case, I can split up my chart, right, at 2 and 8 seconds. So if I want to make a chart, how am I going to do that? So here we go. We have our interval, right? And then we have our critical number. So 0 is less than or equal to t is strictly less than 2. T equals 2. And then 2 is strictly less than t is less than 8. T equals 8. And then t is greater than 8. Right? By the way, if you'd rather use intervals instead of interval notation instead of the less than or equal to 2 signs, you can, that's fine. And then we have our test t for each interval, right? And then we have a sign of what? What are we looking for a sign of? Sign of velocity, right? Sign of v, and then our conclusion, correct? All right, so our conclusion. So here we go, test t. So I'm going to just pick an easy number in between. 1, 2, 5, 8, 10. Does that work? Everybody good with those test t's? Okay. Sign of the velocity. Well, what was our, it was t minus 8 times t minus 2, correct? So we just need to know if it's positive or negative for each one. If I plug in 1, I get negative times negative, which is positive. So which way am I moving? Right. And of course, if I plug in 2, what do I get? 0, so I'm stopped. If I plug in 5, 5 minus 8 is negative, times 5 minus 2 is positive, negative times positive is negative, so I'm moving left on that entire interval, because I'm going to move in the same direction until you stop, correct? So I can't change in between 2 and 8 on which direction I'm moving because I don't stop. You can't change directions if you don't stop, okay? And then anyway, I get 0 here, so I'm stopped again. And then, of course, if I plug in 10, 10 minus 8 is positive, 10 minus 2 is positive, positive times positive is positive, so I'm moving right. So those are stop and turn around points, right? So I can put TA for turn around at the stop. So either stop and keep going or you stop and turn around. These happen to be 2 stops where I turn around and go the other direction, okay? And then I can come up with my chart. I'm not going to take time on this because I think I did it in the video. But anyway, if I graph this thing, here's my position. 0, if I plug in 0, I got negative 2, didn't I? So I start at negative 2 when t equals 0. Plug that into the original S. So S was 1/3 t squared minus 5t squared plus 16t minus 2. If you plug in 0, you get minus 2. So that's where I start, and then I was moving to the right, correct? Until I got to 2 seconds. If I plug in 2 to that, so S of 0 equals negative 2. S of 2, my first stop, is 12 2/3, just so you know. Okay, I'll let you plug that in to figure it out. So I'm going to go over here to 12 2/3. Okay, moving right till then. So I put a little arrow to indicate direction there. And then I'm going to stop and turn around. I'm going to come back and go left until I hit 8 seconds. And then if I plug in 8, I actually get negative 23 1/3. I'll let you verify that. Okay, so there are times to use a calculator. Okay, I understand when you get awkward numbers, yeah, I don't care if you use a calculator, but we need to know how to do stuff with concept as well, right? Anyway, so I come, I'm going to go, here's negative 23 and a third, 23 and a third. So I'm going to come back and go left till here. So I'm going left. That's a long line, so I'm going to kind of show that again. And then I'm here, and that's at t equals 8 up here, right? 8 seconds. This was at t equals 2 seconds. And then what do? I go right. I don't even need to, I just go right from there. So there's my stop points, right? How's that look? Nice and sloppy? That's why I hate using my computer. But anyway, there you go. That's a nice little chart, right? So then what happens is we're going to get into acceleration. So I do want to note acceleration is going to be your pull. That's not how you spell it. Acceleration. Acceleration is your pull. Okay? So here's the deal. We talked about a rubber band, or like a big band that if you've done running drills and track or football, things like that. If someone is pulling you in the same direction you're running, you're going to speed up, correct? But if they pull against you, you're going to slow down. So if the velocity is negative, you're moving left. But if you have negative pull, which means the acceleration is negative, and you're running left, and you're getting pulled left, you're going to speed up in that direction, correct? Does that make sense? If you are running to the right, your velocity is to the right, and you have positive acceleration, which means the pull is to the right, you will speed up to the right. However, if I'm running to the right and my acceleration is negative, which means I have left pull, I'll be slowing down, right? Okay. And if I run to the left, but my acceleration is positive, so my velocity is negative, means I'm going to the left, but my acceleration is positive, which means my pull is to the right, I would also slow down. It only took me about 25 years to figure out acceleration, but we also know that acceleration is the derivative of the velocity, right? V prime at t. It's also the second derivative of the position function, correct? So for the one that I had, we had velocity was, what did we come up with? T squared minus 10t plus 16. If I want the acceleration, that's going to be v prime. It's the derivative of that, right? Which is 2t minus 10. So the acceleration is either going to be positive, negative, or 0, right? So I want to see where this equals 0, correct? And then I can always use that in my chart method. So setting that equal to 0, t equals 5, right? 5 seconds. I have zero acceleration, which means no pull. Okay? So what I can do then is I can, I believe this one's in a video, but I can do a new chart now. I have my interval, I have my test t. I want to know what the sine of v is, right? To know if I'm going right or left. I want to know what my sine of my acceleration is, so I know which way it's pulling, and then I have my conclusion for my particle. So in this case, now I'm going to have 0 is less than or equal to t is less than 2. I have t equals 2. Then I have 2 is less than t is less than 5. So I have critical numbers where the derivative of the velocity is 0 and where the derivative of the acceleration is 0. So I have another number here. So t equals 5. And then I've got 5 is less than t is less than 8. T equals 8. And then t is greater than 8. Right? And then my test t's here. Here I might say 4, 5, 6, 8, 10. Right? I already had my sine of v. I was going right, correct? So it's positive until I hit 2. And then it was 0. And then it's negative. So these will still end up being negative from between 2 and 8. But I have more negatives to put in. Then it was 0. Then it was positive, right? So I know that I'm going right. I'm stopped. And turn around. I'm going left, left, left here. And then stop and then right. But then what I want to do is I want to figure out my acceleration. So 2 times t minus 10 or 2 times the quantity t minus 5. Plug it into t minus 5. I plug in 1, it's negative, so I got left pull. I'm going right, but it's left pull. So what's my particle doing? It's going against it, right? So I slow down. So they slowing down, and then here the acceleration is still negative, so it's stopped and it's pulling left, still pulling left. So you can be stopped and still have that rubber band pulling against you, correct? And then here, it's negative, so now I'm going left but speeding up. And then I'll let you finish that for the different ones. Check out the videos. So I'm expecting that you have all the information that you need with my videos for section 2.5 to finish that up. I know some of you got some other things going tonight as part of being a student athlete. Good luck. If you got questions, let me know. See ya.
Can you sign this?